Welcome to Spacecraft Guide, the channel that goes over the most iconic spacecraft in the world. In this issue of Spacecraft Guide, we are going to continue to show you how to fly the spacecraft, and also at the end of this video I'm going to show you how to get the book that the text was actually launched into outer space to test to see the viability of the text in outer space, if anything, any cosmic rays or anything will affect it. So that's at the end. But before we get to that point, we are going to work on another control. And this controller actually acts like the control surfaces of an airplane in outer space. And because there's no air, it works on gases. And it is the Translation Hand Controller. And when you click on it, it takes you to the Translational Hand Controller page. And you can see here, right here, this part right here is a handle or a controller that goes left, right, up and down, and in and out. And why does it do it? Well, it's used for the manual control translation along the longitudinal, lateral, and vertical axis to the axis to control the RCS, which is the reaction control system. Those are basically the thrusters that move the spacecraft in outer space where there's no air, so the control surfaces on the shuttle don't work. There are two translational hand controllers, one at the commander station, which we see here, and one at the flight deck station, which is totally around in the back, and that's used for docking with things like satellites or also the International Space Station. The commander's Translational Hand Controller, THC, right here, is active during orbit insertion, on orbit, and during deorbit. The Aft Flight Deck section Translational Hand Controller, which is totally 180 degrees behind the commander, is active only in orbit. Okay, the Translational Hand Controllers are used for manual control of translation along the longitudinal, X, lateral, Y, and vertical Z axis using the RCS. So, like I said, in outer space, there's no air. That means like the elevons that use for roll and pitch, and on the rudder that use for yaw, they don't work. So what you need is an artificial system to do that. And in space, we use Newton's force equals mass times acceleration. So the force is created by thrusters, and this controls the thrusters. So if you want to move the shuttle to the left, you move the Translational Hand Controller to the left. You want to move it to the right, move the shuttle to the right, you move the Translational Controller to the right. If you want to move the shuttle up, you move the THC up, and if you want to move it down. Now here's the interesting thing. If you want the shuttle to go forward, like with docking, if you push the Translational Hand Controller, and that moves the shuttle forward. It fires the thrusters towards the rear. And the other way, if you want to go back, if you're undocking, or if you're coming in too fast to the International Space Station or some other thing, you pull back, and that moves you backwards, or it fires the forward thrusters. And that makes this a very important controller. But they also limited it even further. As you can see, this one, which is at the commander's station, is active during orbit insertion. So when you're going into orbit, if you need to move the shuttle in a direction to get into orbit, and you're in basically outer space where there's no air, that's where you have to use that. And also during deorbit, to get it out of orbit, this is what you're going to use, again, because there's no atmosphere. And then the one that's in the back, the Aft Flight Deck Station, that you can only use in orbit. And the reason why in the back is that's where the docking station is in the back of the shuttle in the bay. And you have to see how the docking station is going into it. So it's actually back here. You see these windows. I just happen to have a good view here. Those windows, those are used for docking. So the airlock, the docking station is back here, and the controller is back here, where the commander system is towards the front, these front windows. This is in the back. And that's how, in orbit, when they dock with something, this is where they're going to dock. So there you have it. That is the thrust hand controller for our YouTube viewers. Now, if you want, I have a big special here at the end of this video. I'm going to show you how to get this book, but the big thing about this book is the text was sent into outer space, and the reason why I sent it into outer space is I wanted to test and make sure that the integrity of the text would still handle the extremes of outer space. So you'll see in the book that I'm saying that this text actually went into outer space, and we tested it for a few minutes in low Earth orbit, sort of like Virgin Galactic or Blue Origin, where you go up for into outer space, basically above 100 kilometers, above 60 miles, 62 miles, and getting all exposure to what's in outer space. That's what happened to this book. So if you stay till the end of the video, or at the end of this video, you'll see how to get this book. But if you are a Patreon subscriber, even a free Patreon subscriber, which means it doesn't cost you anything, we're going to go into the schematics of how this handle works physically. And we're going to use a diagram here of the RCS thrusters. So if you are a free subscriber, and that means it doesn't cost you anything, or if you're a paid subscriber, we're going to go into schematic. And if you're not a free subscriber, what are you waiting for? It's free. So you'll see also how below you'll see how to go to my Patreon page so you can sign up for free. But if you are a Patreon subscriber and you click on schematics, it takes you to the RCS, the reaction control system, jet identification. So these are the thrusters along. And you'll see here we have pitch, which is up and down, yaw, which is left and right, pitch and yaw. And then there's also roll access. And then there's also up and down, and it's all from these thrusters here. So if you want to yaw or turn the nose of the airplane, you'd fire these in the front and these in the aft, and that would, if you're firing these ones, you're moving to nose here this way to the minus direction, or to the port side, which if you're looking to the front of the spacecraft, that's to the left. If you want to pitch up, you fire these thrusters down here and these thrusters up here, or back here, and then that'll pitch the nose up, and then the exact opposite. But here's the interesting thing. If you want to move the whole spacecraft, let's say to the right or to the starboard side, if you're looking at the nose that's going to the right, you would fire all the jets on the left side, and that would, with force equals mass times acceleration, that would move it. And that's when you move the thruster of the translational hand controller to the right, it fires all these thrusters on the left. And if you want to go to the left, again, you fire all the ones on the right, and that would move you to the left, or to the port side, or to this way, to the Y direction here would be to the minus side. All right. Now, if you wanted to go up, you move the translation hand controller up, and this would move the direction up. So all of these on the bottom, and the forward and the aft, they would fire, and that would move the shuttle up. Now, if you want to move it down, you would fire down with, you would fire all the ones on the top here, in the front and in the back, and that would move the shuttle down. Now, if you wanted to go forward, so we have Y and Z, now you wanted to go X, this direction you wanted to go forward, you would fire the thrusters in the back. If you wanted to go backward, you would fire the thrusters here in the front. And that is how we replace the controllers of the spacecraft with the flight controls of the spacecraft that we call the ailerons. We replace those with thrusters because basically your control surfaces don't work in outer space because there's no air. So that's how this the space shuttle works with the hand controllers. Now that is all for our free subscribers. If you are a paid subscriber, which is $5 a month, and for $5 a month, you know, that's like a cup of coffee at one of the one at a Starbucks. You know, for $5 a month, you get to learn a lot more about the space shuttle, and you get to help support me do all this kind of stuff and teaching others besides you on how space flight works and bringing up the intelligence of the human race, basically. So if you are a paid subscriber, we're going to go down a little bit here. You can see the thrusters, but we're going to go down to this panel right here, and we're going to use the forward RCS reaction control systems. And here you'll see the putting the thrust into it for or how this forward RCS makes thrust. As you can see, we have the right here we have the oxidizer and the fuel, and when you what we do is we mix these in the jet, which or in the thruster, which is up here. As you can see, we have the injector, we have the nozzle here in the combustion chamber, and here we're putting in the oxidizer, which is oxygen, and the fuel, and it combines in here and produces the thrust. It produces the bang that moves in the thruster. Now, the big thing is these oxidizers. Some, you know, when the tank is pretty full, we need to move that oxidizer and that fuel. But when it's not so when there's not that much, we have to use another gas, and here it is. It's helium, and that helium gas, you see, there's helium for the oxidizer and helium for the fuel. That is going to push more of the fuel out of the container, and the reason why we use helium for both of these is because it's inert. Helium is inert, which means that when it contacts the fuel, it's not going to do anything. It's going to push the fuel out. Instead of acting like an oxidizer and hitting the fuel, the helium will not start a flame. It'll just push the gas out to mix with the oxidizer through here. All right. Now, it's the same for the oxidizer. When we have the helium here, it's pushing the oxidizer into the system. It's not reacting with the oxygen. So, since it is inert, it pushes the gas without reacting with it until it gets to the nozzle here in the combustion chamber and produces thrust. So, that is what I have for you for this week. Next week, we're going to start on a new system. We're going to start on the reaction control system. So you're going to get a hint. It's going to be talking about this, and we're going to go in comparing into the how this system goes back all the way to the X-15, and that's going to be something special for you, and that's because you are my best supporters. And you guys, by paying, you support all of
This
this
is
stuff that I'm doing
literally
here,
my
trying
book
to
launch. I
get the
took the
information
contents of my
out to
book
people
and I
to
launched it
learn
on this rocket
more
into outer
about
space to test
these
its
systems
digital
here
integrity.
and how we actually operate in space, and that it's actually possible to do it. So for all of your support, all the voices that tell other people to help join us, and for your monetary support, I thank you. And this is the book, Flying the Space Shuttle, A Pilot's Guide to Orbital Flight, Digital Autopilots, and Spacecraft Navigation. Now, this book is actually, the text itself has been sent into outer space as part of a documented test of electronic information integrity in the space environment. And this is the original source manuscript whose text was intentionally selected, prepared, and transmitted or transported beyond Earth's atmosphere as part of a documented spaceflight data integrity experiment. So you can actually check out this book here and see it. You can read a sample if you come down here, read a sample. This will be what you see. So you can actually go through. What I have in here is the first chapter, and it is going to explain what the instruments are on the space shuttle and tell you what each component is. Now, the first chapter goes over very quick summary of what the instrument is. If you go into the book further, you can see on the chapters here that you go into the parts, the airometers, the rate indicator, all of that you will be able to look at in the book. But right up to here, you get to display on, or you get to view on the Amazon site, and the text that we put onto the spacecraft and launch goes all the way down to chapter 4. That's as much information as I could squeeze into my space that I was allowed to into the satellite or into the rocket that went into outer space. And this is my certificate that tells it that it went into flight. Now, on October 27th is when I loaded it onto the rocket, and it went up into space later in November. And one of the great things down here is if you scan that with your computer, you can see the text that was actually sent into outer space, and it'll be in identical to the book, except there might, or there is in the text, it says test flying. It's my first book in space, test flying the space shuttle. Now, the reason I did that is to document. So, test, test, test. If you want to get the test, 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 to the author's knowledge, this marks the first publicly documented case in which the original manuscript of an Amazon Kindle ebook served as the primary text source for a recorded outer space transportation prior to its publication. Well, this was the source document, so this is before the publication of the next book that I'll have out. This is the original source document. And again, right here, if you click on Read a Sample, you can actually look and see the contents of the book even before you buy it. And it goes over Chapter 1, the primary flight display, which is basically an overview of what the astronauts see when they're flying the shuttle. And it's pretty similar to what they fly on SpaceX or the Artemis rocket that goes into outer space that is going to go to the moon coming up in February of 2026. So if you want to see that, you can come down here, or you can see and read about those instruments here.